So, good morning, one and all. So, welcome to the course Deep Learning. So, for this course, we follow these NPTEL videos. So, there is no syllabus as but so we'll try to cover the NPTEL syllabus itself. Now, so before moving further, so let us see the most state of art technologies that are available today. So, you might have seen or you might have heard about artificial intelligence and machine learning and deep learning. So let us see the basic difference between these three. First of all, this artificial intelligence. So what do you mean by this? Okay, in this what we do is we enable a machine or a computer to think on its own. Otherwise, we enable a machine to take decision on its own without human intervention. Okay. So for example, self-driving cars. Okay. They take their decision on own without any human intervention. So that is basically comes under artificial intelligence. Okay. Now, so the subset of AI is ML, that is machine learning. Okay. A subset of AI is ML. So in ML, what we do? ML means machine learning. There, what we do? So it is basically a statistical tool to explore or analyze the data. What is ML? It is a statistical tool to explore or analyze the data. Okay. Now, so what is deep learning? It is a subset of machine learning. Okay. Now, what exactly deep learning means? Here, we make a mission to learn just like humans. Okay, which means we need a mission or a device which can learn just like humans. Okay, so it is about learning. So we need a mission which learns just like humans. Okay, that is a deep learning. Okay, now here we use multi-neural network architecture. Okay, we design or we model architecture which can learn just like humans. Okay, now this is about the basic idea of AI versus ML versus deep learning DL. Okay, so in deep learning we have some varieties, something like this. They are artificial neuron network. You might have known all these things. CNN, convolutional neural network, and RNN, recurring neural network. Okay, so without wasting much time, let us get into the topics. Okay, so basically, over the past decades, we have seen the very prevalent technologies are AI, ML, and DL. Okay, so DL happened to be most prevalent technologies in the past few decades. Okay, now it has got applications in speech processing, computer vision, as well as NLP. NLP means natural language processing. Okay, so now so the most fundamental unit of a deep neural network is known as a artificial neuron. What is that? So the most fundamental deep neural network is an artificial neuron. It is something like this. Okay. So it has got some inputs. Okay. And some weights. So here we have a mechanism which can take decision. Finally, output is Y. Okay. We'll come to this later. Before that, so neuron, the term neuron is derived from where? Where do we get inspiration from? So we get inspiration from biology, especially from the brain. Because what is brain? It is a collection of neurons. Okay, first we'll study a neuron, a typical biological neuron. Okay, so this is about a typical biological neuron. Now, so what is neuron? It is a fundamental unit of a nervous system of a human being. What is it? It is a fundamental unit of a nervous system. Now these neurons generate electrical signals. What do they generate? Electrical generate. Okay. Now it has got some parts. First is dendrites. What are dendrites? They are the part of the neuron which take input from the other neurons. What are they? So they are the responsible for getting incoming signal or input signal from the other neurons. Okay. So in the brain we have a hierarchy of neurons. So from other neurons we get information from the information to this neuron via these dendrites. Okay. So next body is soma. Soma is a central body. Okay, it is a processing unit which takes a decision based on the inputs. Okay, so soma is a cell body responsible for processing the input signal and deciding whether a neuron should be fired or not. Okay, so what do you mean by this is whenever a neuron passes electrical signals, it is called fired. What do you call? We say that the neuron is fired. Okay, please remember this. Now next is axon. What is axon? So it is responsible for transmitting the output of the neuron. Okay, it transmits the output of the neuron to the another neuron. Now we have synapses. So the last part of the uh, biological neuron. So it is a point of connection to other neurons. Okay, so it will connect with the other neurons using this synapse. Okay. Anyway, so this is briefly the uh, typical biological neuron. Okay, they are the fundamental units of our nervous system or our brain. Okay, you just remember these things. Okay, it has got some axon, dendrites, cell body or soma, and synapse. Clear? Now, so now let us see how the neuron works. Okay, now here before that, our brain has got so many neurons, around 10 power 11 neurons. An average human brain has got 10 power 11 neurons. Okay, now so we have a massively parallelly interconnected hierarchy of neurons. We don't have a single neuron, we have a massively parallelly interconnected neurons. They are arranged in a hierarchy. Okay, something like this. Okay, we have a hierarchy of neurons in our nervous system or in our brain. Okay, so how do they work? First of all, our sensory organs like nose, ear, and eye. Okay, so they interact with the outer system. Okay, these neurons will interact with the our sensory organs. Okay, now what have you written? Our sensory organs interact with the outside world and they pass information to the next neuron. Okay, now so these neurons will interact with the sensory organs and they pass information to the next neurons in the hierarchy. Okay, suppose so if something is funny, okay, suppose when what you see is funny or what you hear is funny, these neurons will be fired. Fire means they will pass the electrical signal to the next level of neurons. Okay, now here the neurons which are fired are shown in the red color. I hope you can see this clearly. Okay, neurons which are fired are shown in the red color. Okay, so if you see something which is funny, if you hear something which is funny, what will happen immediately? The neuron starts fire, or which means they start conducting the electrical signal to the next neurons. Okay, those are shown in the red color. Okay, if it is not funny, they don't fire. If it is funny, they fire. So finally you may laugh. Okay, this is action taken or this is a decision. Okay, so whether to laugh or not is decided by these neurons. Okay, what they do, they pass information to the next neurons if it is funny. Whatever you see is funny or whatever you hear is funny, so the neurons will fire to the next level of neurons and finally the brain will take the decision whether to laugh or not. I'm telling you a simple example. Okay, what will happen? Yeah, so neuron is fired is red color. Yeah, one more thing, last. So, so each and every neuron has got its own job. Okay, each and every neuron has its own role to play. Okay, why? Because here we have as neurons. Some neurons may process the visual data. Some neurons may process the visual data. Some neurons may process the speech data. Each and every neuron may not take the decision for all type of data. Okay, so there is certain role for each and every neuron. Some neurons may process the visual data. Some neurons may process the speech data. Something like that. Okay, so there is a division of work. What I want to say is there is a division of work. Work is divided among the neurons. Some neurons are allocated certain tasks. They perform those tasks only. Okay, so that job will be easy. Yeah. So this is a simple example. Yes. So let us take one more thing. This is how the neuron works. How they work? So they will the lower level of the neurons will interact with the our sensory organs like eyes, nose, uh, maybe ear, something like that. Okay, so they take the decision whether to give some action or not. So if it is funny enough, they fire. So they pass information to the next level of neurons. So this happens finally. Our brain will take decision depending upon our input from the our sensory organs. Now there is a division of work among the neurons. Some neurons are allocated for particular task, and there is a parallelly interconnected hierarchy of neurons. We have 10 power 11, approximately 10 power 11 neurons in our brain. Okay, these are our brain works. Okay, now, so this is a part of brain. It is called visual cortex. Okay, so visual cortex means a part of the brain which processes visual data. Okay, we are not dealing with all the brain anatomy. Here simply we are dealing with visual cortex, which means it is a part of the brain which process the visual data. That's it. Now how the information flows start from retina, it goes to the this part, next this part, next this, next this, so on so on. Finally the output is given to the our spinal cord. So the spinal cord will take the decision whether to move the muscle or not. Okay, so when you see something, what action? Moving the muscle. It could be anything, right? So the output is moving the muscle. Input is given from the retina. Okay, now so these are our brain works. Okay, so but here we concentrate only on the few parts, V1, V2 and AIT. Okay, what is the job of these three? We have a flow of information from here to here, from the retina to the spinal cord. But here, so let us see what happens at V1, V2 and AIT. At V1 what happens? Okay, so V1 it detects edges and corners. What it will do? It detects edges and corners. The job of the layer 1. Where is the layer 1? Somewhere here, V1. Okay, it detects edges and corners of the image. Okay, for example, face, human face. Layer 2, it joins the, it groups or joins the these corners or edges and comes out with a meaningful feature or recognizable feature. So suppose if you join these two, it may something like mouse or nose. These two can be like mouth. If you join these two, it can be like something like eyes. Okay, that is done by layer 2. Here it is V2. And AIT, what happens is, so in AIT we have a high level of processing. Okay, so by combining all these things, it concludes that it could be a face of a human. Okay, so in our brain there is a high level of processing will happen. Okay, Now this is how our brain works. Okay, simply I am dealing with visual cortex means a part of brain which process the visual data. Okay, anyway, so brain performs very high level processing, but we are simply we are dealing with only a part of the visual data. Okay, right? Now, yeah, so there's a disclaimer. It is simple thing. I understand very little about the human brain works, but this is efficient. This is sufficient for our course. Okay. Now this is how our brain works. Okay. Now so far what you have done? So we have seen uh, the major difference between AI, ML, and deep learning, and this is the application, some application of deep learning. So the deep learning, so basically we deal with artificial neurons, but the inspiration from for this artificial neuron is our biological neuron. This is a typical diagram of the our biological neuron, which contains some parts, and we have seen those the importance of these parts and how the neuron works. We have taken a simple illustration example. Okay, this is how our brain works. This is about visual cortex. So anyway, so let us getting into the topics now. So here now what happened here is, so McCullers and Pitts, they first given a mathematical model of a biological neuron. Okay, so we call McCullers and Pitts. McCullers and Pitts. So these two combinedly has given a mathematical model to the our biological neuron. Okay, simply we call MP neuron. MP means McCullers Pitts neuron. In the shortest form, you can call it as a MP neuron. So from now onwards, we call MP neuron. Now this is a model of a MP neuron. Okay, it mimics the our biological neuron which are present in our brain. We try to model our brain neurons with the a mathematical model that is called MP neuron. MP means McCullers Pitts. These are two scientists. So who are they? So McCullers is a neuroscientist. Pitts is a logician. Okay, anyway, so they given a model called MP model. That's it. Now it has got two parts, G and F. It's got two parts, G and F. What is the purpose of G? It takes inputs. G takes inputs and aggregates those inputs. Aggregating means making the sum. Okay, so the job of the G is to take the input and performs an aggregation on the inputs. What is the job of F? Based on the aggregated value, F takes the decision. F takes the decision. Based on what? Based on the aggregated value of the G. Okay. Anyway, so here the inputs and outputs are Boolean. Boolean means either 0 or 1. So for simplicity, we consider inputs and outputs of a MP neuron are Boolean, 0 or 1. Yeah. So one more important thing is, if the input is 0, something is 0, we say that the neuron is fired. Sorry, 0 means neuron does not fire. 1 means neuron fires. As I told you, firing means it transmits electrical signal to the next neuron. That is called firing. So if it is 0, neuron does not fire. If it is 1, neuron fires. Okay. Now, suppose let us take simple example. So, how do you take a decision whether to watch a movie or not? Okay, let us take simple example. How to decide whether I should watch a movie or not. I should go for a movie or not. Okay, you may take so many things into consideration. Okay, so many factors into consideration. Factors could be, in my opinion, I have written, but it could be different for different persons. Is it okay? So you may look for your favorite actor or actress, your favorite director, or and rating of the movie. If the rating is good, you may prefer to go. Okay, so based on these factor, you take a decision whether to watch a movie or not. Okay, now here, so what are inputs to the neuron now? Who is the actor or actress? Who is the director? What is the genre of the movie? And what is the rating of the movie? So based on these factors, you take decision. Okay, whether to watch a movie or not. Okay, now here, so there are two types of inputs here. Okay, what are they? They're called inhibitory inputs and excitatory inputs. What are inhibitory inputs? Are that they have a maximum effect on the decision making irrespective of other inputs. Inhibitor input means they have a maximum effect on the decision making irrespective of other inputs. So for example, so we have a inputs like suppose the movie is your favorite actors or actress movie. Okay, the movie is directed by your favorite director and it has got good rating, even though suppose there is a one more input that is x4. So on the particular day you are sick or you may have interview. Okay, so what will happen here? Even though the movie is of your favorite actor or actress, your favorite director, it has got good rating. In spite of all those things, what is the output? What is the outcome? Zero, because you are sick on the particular day or you have some interview on the particular day. Okay, now the x4, okay, the fourth input is called inhibitory because it has got maximum effect on the decision making irrespective of other inputs. I hope you got my point, because even though the movie's favorite hero, your favorite hero or heroine or favorite director or it has got good rating, but you cannot go to movie because you are sick on the particular day or you have some interview on the particular day. Okay, now these the fourth input is called inhibitory because that is a it is affecting the decision more predominantly irrespective of other inputs. Okay, now so here what I written, so maybe you may seek on the particular day something like that. So if it is so, obviously output is always zero. Why? Because you are sick, you cannot go to a movie even though it is your favorite hero's movie or favorite heroine's movie or favorite director's movie or it is got good rating, because you are sick or you have some other work, some other important works. Okay, now that particular input could be called as inhibitory input. Okay, next, excitatory input are not the ones that will make the neuron fire on their own. So remaining inputs are called excitatory inputs. Okay, so they don't make the neuron to fire on their own. Okay, but so the combination of some inputs can make the neuron to fire, but on their own they cannot make the neuron to fire. Is it okay? Now, so this is about a simple mathematical model of a Michaelis Spitz neuron, or simply called as MP neuron. Yeah, so let us go to the little bit of mathematics. So what they will do, we have n inputs which are Boolean in nature. We have two parts, G, F. What is the job of G? It takes the summation of all the inputs. This aggregation means summation of all inputs. G will sum all the inputs. What F will do? It takes the decision based on the sum value. Okay. So what is output? Output is a function of G of X. Now, so what we do is, if the sum is, we keep a threshold, theta. Theta is called a thresholding parameter. So if the sum is more than the threshold, output is 1. If the sum is less than threshold, output is 0. Okay, which means, so finally the G part will sum all the inputs, and here we keep a threshold. Obviously, we need a threshold for every and each and every decision. So if the sum of all the input is more than the threshold, output is 1, which means the neuron will be fired. If it is less than threshold, output is 0, which means neuron does not fire. Okay. Okay. So anyway, we stop here for this day. Thank you.